We're very pleased to announce our new StarSense Explorer Dobsonians. The telescope tube features a larger aperture than the other StarSense Explorer telescopes. It also has a 2-inch Kuiper focuser that accepts both 2-inch and 1.25" format eyepieces, and also has a custom pointing knob to help you precisely aim the telescope at your target. Both the tube and base have carry handles at their balance points, and of course, the exciting StarSense Explorer dock. Simply place your smartphone in the dock and launch the app. Choose from the best objects to view, then just move the telescope to follow the arrows to your target. When it's ready to view, the bullseye turns green. It's easy to do because of the patented StarSense technology.
Hi everyone, we hope you'll enjoy the presentations we're bringing to you virtually from the Texas Star Party. We wanted to thank everyone who has taken the time to make this event what it is. TSP is a 501c3 nonprofit organization, and it's made possible every year by the help of people just like you. If you like these presentations and would like to help further the Star Party, you can throw a few bucks or a few thousand in our virtual tip jar by donating today. And it's tax deductible too. Make sure to share these videos with your friends, any clubs you're a part of, and most of all, remember to have fun. We hope to see you in person next year.
So many levels, it is incredible. He earned his his Bachelor of Science degrees in physics and astronomy, his master's in aerospace engineering and planetary atmospheres at the University of Texas at Austin, and earned his PhD in astrophysics and planetary science from the University of Colorado, Boulder. He is best known as the principal investigator of the New Horizons mission to explore Pluto and the Kuiper belt, but his long career in exploration spans the entire solar system. His space science research spans more than 3 decades, including key roles in missions such as the upcoming Europa Clipper mission, which will explore Jupiter's ice-covered ocean moon, the Rosetta mission to orbit a comet, and the Lunar Reconnaissance Orbiter currently orbiting the moon. He's also done research using sounding rockets and a space shuttle deployed satellite. These are accomplishments that would make anybody enviable, and as am I. In 2007, Dr. Stern was listed among Time magazine's 100 most influential people in the world. In 2015, he was the recipient of the Smithsonian Magazine's American Ingenuity Award in the Physical Sciences category. In 2016, Dr. Stern was inducted into the Colorado Space Hall of Fame. We are very fortunate and honored to have him with us tonight. And without further ado, Dr. Stern.
Thank you for that generous introduction, and it's great to be here. The few of you that I've had a chance to talk to since I arrived this afternoon, many of you probably don't know in the audience, when I went to the University of Texas as an astronomy student, I came out to McDonald a lot, and I observed on virtually every telescope on the mountain that was there at that time. Is this better? Does that work for you? Cool. Okay, we're good. So I know this area pretty well. It's a pleasure it's kind of old home week for me to come back to Fort Davis area. And I'm going to talk about one of my favorite topics. I'm going to talk about the New Horizons mission and sort of tell you a little about the story of New Horizons, and then a bunch about the results and about what's available, what we're going to be doing next. And where's the clicker? There it is. So I don't have to stand right here. So, New Horizons is really an epic journey of exploration. This is a cartoon view of the solar system. And you know, the solar system as we know it today really has three zones. There's the inner planet zone, which is the outer border of which is the asteroid belt. And then you have what used to be called the outer solar system, where the giant planets are. It's really now the middle solar system, because the Kuiper belt was discovered. And that's the third zone of the solar system. New Horizons is the first mission to explore the Kuiper belt. It was launched in January of 2006, flew to Jupiter for a gravity assist to speed us up further the next year, and then a long traverse of the solar system to intercept Pluto in 2015, and then off into the Kuiper belt for the next decade. Now, I thought I'd say a little bit about my background. I didn't realize I'd get such an involved introduction. And so I'm going to take a little risk here with this next slide. I thought I'd start with, that's me. That's my first scientific instrument. It's looking the wrong direction, down instead of up. But my parents were great about, recognizing I had an interest in science. And my father was a salesman, and my mother was a housewife, but they knew I was just devouring books on it and so forth. Probably many of you the same way. So they bought me telescopes and microscopes and chemistry sets and lots of other opportunities. But all I ever wanted to do as a kid, all I ever remember wanting to do, didn't ever want to be a fireman or a policeman or a lawyer or anything. I just wanted to be involved in space exploration, and I was very fortunate to grow up and get to do that. And my career's been a lot of fun. I've been involved in over 400 scientific papers in the refereed literature. I've been on 29 space missions. New Horizons is probably the most famous. But I also spent 5 years flying F-18s and U-2s for NASA, flying backseat, doing astronomy from those high-altitude platforms. I did research down at the South Pole in 1996 with an infrared telescope called Spirex. And last year, in July, I was invited and I accepted to go on a submersible down to the Titanic. And that's a talk in and of itself. We could spend an hour on that. Amazing experience. I took this picture with my iPhone. We were about 10 meters off the bow. You can see everything there that you expect from the movie, except where's DiCaprio? And next year, or maybe late this year if we're lucky, NASA has selected me to fly as the first researcher on a Virgin Galactic suborbital space flight. And I actually am selected for 2 flights now, so that'll be the first of those pair. And as I said, I've been involved in 29 space missions, not 29 proposals for space missions, 29 things that have flown in space, from suborbital sounding rockets to space shuttle missions to planetary missions. And of all of them, New Horizons is my favorite. It's the most audacious. And I'll tell you a little story about planetary science. In my field, the most prized missions to get on are the first missions to a new planet or to a new class of objects. And in the generation, the first generation of planetary scientists in the space age, Carl Sagan's generation, people who were my parents' age, they got a tremendous opportunity because in one generation, in their generation, the United States blazed a trail across the solar system, every planet from Mercury to Neptune. By the time my generation came online, I got my PhD in 1989, the year that Voyager explored Neptune. And then it was done. And there was only one option left to be a first mission to a new planet. At least that's what we thought then. For different reasons than you may be chuckling. And that was Pluto. And New Horizons is it. It's really the mission of my generation to go to a whole new region of the solar system, explore a whole new class of objects, and I'm going to tell you all about it. Now, what is this? It's Pluto. It's the very best picture of Pluto ever made before New Horizons showed up. And I was the principal investigator of this program. This is made with the Hubble Space Telescope. We took these data in 1994. We published in 1997. We wrote a series of scientific papers on this blurry blob. Can't you see the northern polar cap? This is really the lesson of why we go to the planets, is because we find out over and over again that our Earth-based observations just don't have the resolution to really understand. And so, fortunately, spaceflight came along at just the right time. This is the kind of resolution that you really need if you want to understand a planet, not something blurry like that Hubble image of Pluto, right? This is an Apollo 17 image of the Earth as they were leaving for the last expedition to the moon of the Apollo series. Now, this is the Earth blurred to Pluto resolution with Hubble. How much can you learn from that? It's blue. Not much. What's that? Great guess, completely wrong. You see, you need to go there. Works every time. Anyway, I made my point. So the thing about this is it's very expensive because it's very complicated. And it requires thousands of people to build the launch vehicles and the spacecraft and all the scientific instruments for these probes. And so you have to raise a lot of money. And this is not something you do with crowdfunding. What you do is you essentially enter two competitions with NASA. The first is to get them to fund the mission, and they're getting dozens and dozens of great ideas. Yours has to float to the very top. You have to get it there. And for scientific reasons, not just because it's cool. And then, when NASA decides to fund it, they'll have an open competition for which team is going to lead the mission. And then you have to win that too. So you have to win two sweepstakes. And we spent a long time trying to convince NASA that it was worth spending almost $1 billion to go fly to Pluto. And there were lots of naysayers. There were people like, it's too far, it takes too long. I had one scientist, a very distinguished National Academy of Sciences member, say to me once in the early 90s when I was arguing for a mission to Pluto, he said, 2015, everyone will be dead. Well, everyone in his shoes would be dead. But this was a great barrier against doing it, and we just couldn't convince people very easily that despite the fact that we knew Pluto was a double planet and had an atmosphere and interesting surface markings, even at low resolution, and a really complicated surface spectrum that indicates there are 3 different mobile ices on the surface, methane, molecular nitrogen, and carbon monoxide, we get it up in the A list, but we couldn't get it to the top of the list. And there were a whole series of attempts where designs were made, and time after time the mission would never get off the drawing board. Sometimes it was just mismanaged or the cost would blow up. But it really took a lot of persistence. And for the scientists like myself that were working on this in the 90s, it was pretty hard. You know, we started off and we got this Pluto 350 mission on the drawing board, but it fell apart. And then there was a Mariner Mark II mission, it fell apart. And by the time the third and fourth and fifth one fell apart, it was, to say the least, demoralizing. Only New Horizons there on the far right ever got off a drawing board. And here's what made the difference. When most of the people in this audience, myself included, went to grade school, you were taught the geography of the solar system. I'm sure there was one day when the teacher told you, about the 9 planets in the asteroid belt and 4 little rocky planets on the inside, then the asteroid belt, then 4 giant planets on the outside, and then there's Pluto in this crazy orbit, and kind of who ordered that, and didn't fit the pattern. And that was our old view of the solar system until the 1990s. Turns out we had it all wrong because we were limited by the technology, not so much the telescopes. We had big telescopes, but they didn't have the CCDs and the computers to really get the most out of those telescopes. What happened was in the 1990s, we discovered the Kuiper belt, which revolutionized our understanding of the geography of the solar system, that it's not a 2-zone system, but a 3-zone system. But in addition, we discovered the Kuiper belt it is mostly littered with these small bodies called planetesimals. Planetesimals are the building blocks of planets that never got together. They're leftovers from solar system formation. But then we started to discover in the 90s other planets of scale like Pluto. Pluto wasn't an oddball at all. It's just that it was the only one known for 2 generations, from 1930, when Tombaugh discovered it, to the early 90s, when these started to pop up. And now there's a whole slew of these small planets. We call them dwarf planets. And they have the same variety as the terrestrial planets. They're different colors, different compositions, different numbers of moons, and different orbital classes. And so then we could see by the late 90s that Pluto wasn't a misfit. It was just the biggest and the brightest of this entire population that had been hidden to us. And when that became clear, the National Academy of Sciences, in ranking all the mission priorities for the early 2000s, catapulted what had been just a Pluto mission to be a Pluto Kuiper belt mission, catapulted it to the top, because now, by going to Pluto, it wasn't just to study Pluto, but Pluto is an archetype for a whole new class of planet. 3rd class. 1st class being the terrestrial rocky planets, then the gas giants, and then the dwarf planets of the outer solar system. So that's what made the difference, because it got us to the top of the priority queue. Then NASA held a competition. This is the cover of our proposal, the New Horizons team proposal, back in 2001. When I was a kid, 2001 was an imaginary year. It's weird to say back in 2001. But anyway, 5 teams competed to do this, and miraculously, we turned out on top. We worked very, very hard on this, team of about 100 engineers and scientists, and NASA had the 5 proposals. They narrowed it down to 2 finalists. They gave us each $1 million to do an even more in-depth study and proposal, and then they had a shootout, and we won. And I'm often reminded of the thing that the famous NASA administrator James Webb said the day that Kennedy announced that the United States was going to go to the moon. Jim Webb called all of his senior staff at NASA headquarters into a room, and in the vernacular of the early 60s, and this is a quote, he literally said, "Well, boys," you can't do that now, he said, "Well, boys, we got what we asked for, now what do we do?" That's a little bit how we felt, because when NASA selected us, they selected us to launch in this very particular launch window in January of 2006. Now, we were selected in November of 2001, and a typical mission like Voyager or Galileo or Cassini or Europa Clipper takes 7, 8, 9 years to develop. We had 4 years and 2 months because Jupiter was going to move out of position. This was the last Jupiter launch window to get a gravity assist. So all of a sudden we had to do all that work in half the time, and we had to do it for 20 cents on the dollar, 2 dimes on the dollar compared to Voyager. The budget we were given required a lot of innovation. So I always call these years when we were building and testing New Horizons the blur, because it was. And this kind of montage shows you the kind of frenetic activity that was involved. 2,500 men and women worked on New Horizons to design it and build it and test it and fly it, not just the spacecraft and the instruments, but the launch vehicle, the nuclear power supply, mission control, all that business. And it was 52 weeks a year, 7 days a week. And people really rolled up their sleeves and committed in a way that just makes you proud, because they just worked their tail off. And for me, I know my oldest daughter, Sarah, was in high school during this period. She tells lots of stories I have no recollection of. And I was home on the weekends, but gone all the time. By the time we launched New Horizons, I asked my then assistant, I said, Jeanette, how many trips did I take since we won this thing to get us to the launch pad on New Horizons alone, not other projects? And she counted them up, and she said 252. Yeah. Mostly on United Airlines, and if you fly United, you will understand 252 trips on United Airlines is service to your country. All right, this is the spacecraft in cartoon form. For scale, the dish antenna is about 7 feet across. And I'll just give you a quickie tour of the outside of the spacecraft. I think the laser will work. That hair curler looking affair is a nuclear power generator called an RTG, radioisotope thermoelectric generator. It's fueled by plutonium, uses the bottled up heat of the radioactive decay to convert into DC electricity. By the way, plutonium was named for the planet Pluto. So I had the great joy of bringing plutonium to Pluto. 7 scientific instruments with funny names that you see here: imagers, telescopic imagers, spectrometers, plasma instruments, atmospheric sensing instruments, even a dust counter. And then inside the triangular box of the spacecraft is everything we need. You know, propulsion, guidance, computers, memory for data storage, thermal control, communication system, and everything is twinned. We have 2 of everything in case there are failures. And all of it is in a package about the size of a baby grand. The spacecraft weighed about 1,000 pounds at launch, full of fuel. Those of you that are pilots will know the term. It weighed about 1,000 pounds wet. Carried 78 kilograms of fuel. And, you know, if you go to the Smithsonian in Washington, D.C., Voyager's hanging from the ceiling and New Horizons hanging right next to it. And Voyager looks enormous. New Horizons is like, it's like a houseboat and a hamster. But the thing is, just like computers used to fill rooms and really didn't have very much power and they cost exorbitantly, New Horizons, which is tiny next to Voyager, is a tremendously more powerful spacecraft in its capability because it was built with 2000s era technology. A couple of examples. On Voyager, there was a UV ultraviolet spectrometer. It had 2 pixels. And the New Horizons device weighed half as much and had 32,000 pixels. And the infrared spectrometer on Voyager had 1 pixel, and the one on New Horizons, 64,000. And so just like, you know, when we went from mainframes to PCs, they got smaller but more powerful and dirt cheap. The same thing has happened in space, is that we now have lots of CubeSats, even things the size of lunch pails, that are very powerful. But for the early 2000s, New Horizons was state of the art. And we launched it on an Atlas V launch vehicle. This particular one, this is a very powerful, until just last year, this is the most powerful launch vehicle in the US inventory. And I used to be a model rocketeer. How many people in this audience used to do Estes model rockets? Probably not a few. A lot, yeah. And you know, so I spent all of my adolescent years mowing lawns and washing cars so I could get better and better rockets and launch them. You have no idea how much fun I had tricking this one out with every option in the book. Oh, I'll take all 5 solid rocket motors, the lightweight nose cone, and we'll put a third stage on top because your big behemoth isn't powerful enough for what I need. But the idea was to buy the most powerful rocket and put the lightest spacecraft we could on top of it, because the end result is that you can push that spacecraft to record speed to get it across the solar system in a reasonable period of time. And actually, that payload bay, the nose cone, if you will, of that rocket is built to house spy satellites that are the size of a school bus or a moving van. And here's little New Horizons, not much bigger than this table. And I remember the president of the Atlas company said to me once, he said, "You're basically asking us to launch an Atlas V empty." And he said, "You're not going to believe what that looks like when it gets off the pad." Because usually, you see these rockets and they're just struggling, until they can burn some fuel and go faster and faster. Not New Horizons. We took off at 2 Gs of acceleration. This is the spacecraft in the nose cone. I'm standing in front of it. The day that we closed the door on the nose cone, which was Friday the 13th. It was January 13th, 2006. One of my heroes is Jim Lovell, who commanded Apollo 13. And I was having dinner with him once at the Smithsonian and told him the story about this. When Apollo 13 flew, there were a whole bunch of 13s, and he was brushing it off, and then they had this disaster, right? I think it launched at 13:13 universal time, and there were a whole bunch of 13s. And in our case, when we were getting ready to finish up New Horizons there on the launch pad and fuel the nuclear reactor, which is the last step, because then the spacecraft becomes electrically alive, the schedule worked out to be on Friday the 13th. And our launch site manager came to me and he said, "Alan, if that bothers you, we can do it a different day. A couple days later, I'll pay the overtime. Well, it's okay. It's the 13th. I don't want you feeling, jinxed or something." And I'm not superstitious, and I don't believe in that BS. And so I told him Friday the 13th is just fine with me. And that's what we did. And obviously, it didn't affect us because it went just great. This is the launch of New Horizons. Now, there's sound to this, but we're not plugged in for sound. But this rocket is 225 feet tall. It's as big as the biggest building in downtown Austin. And it weighs 7 million pounds. And watch how fast it gets off the launch pad. Those towers next to it are 400 feet high. Now watch, it goes through this cloud layer in about 10 seconds at 10,000 feet. Think of a downtown building doing that. I mean, the F-18s I flew could not do that, even on afterburner. And then we went supersonic, and eventually the solids completed all their burn, ran out of fuel, we shed the solids. And very shortly after that, we were high enough that we could also shed the weight of the nose cone because we were already in space in just a matter of minutes. All this was on the Thursday, the 19th of January, 2006. And here you'll see the solid rocket motors. They come off in 2 waves so they don't collide with one another. There you go. And those are 70 feet tall themselves. They are big bottle rockets. And here you'll see the nose cone come off in 2 halves. There it goes. And then from this camera position, the launch vehicle went behind a cloud. That was the last we ever saw of New Horizons. It was in Earth orbit going 18,000 miles an hour. Minutes later, we coasted around the Earth over to the Middle East where the mathematical injection point was to fire the engines to leave Earth orbit. We finished up the second stage and then lit the solid rocket motor third stage. And the whole stack was so powerful that by the time the third stage burned out, the spacecraft was pulling 14 Gs. Yeah. And was moving so fast that we crossed the orbit of the moon in 9 hours. But the solar system is enormous, and so it took us 9.5 years to reach Pluto, traveling about 1 million kilometers every day in and day out, from 2006 till 2015. The first year and a half was, not a year and a half, 13 months was spent getting to Jupiter. That was a very busy period for us because we had to check out all the spacecraft systems and plan a flyby, get all the instruments calibrated in time to make the most out of the Jupiter Gravity Assist, to do the most for science, but also to flight test everything that we could think of on the spacecraft, the instruments, the planning system, to work out all the kinks so that when we get to Pluto, we had high confidence it would work. And now you'll remember, many of you, or you've read about, in the early days of planetary exploration, virtually every planet that got a first mission sent 2 spacecraft. Mariner 3 and 4 to Mars, Mariner 1 and 2 to Venus, Voyager 1 and 2, Pioneers 10 and 11 to Jupiter. There's a long list of those pairs. And oftentimes only one would make it. We could not afford to fly 2. Remember, it's a fifth the budget of Voyager. So we only had one shot at this, and so we had to really pay a lot of attention to that Jupiter flyby to get a lot of things tested for the Pluto flyby that came 8 years later. We did do a lot of great science at Jupiter, 700 different observations of Jupiter and its moons and its magnetosphere, and I could spend an hour telling you about that, but you've been learning about Jupiter from Scott Bolton and the Juno mission, which is an orbiter and is doing much more than New Horizons ever did. But we took advantage of being there. We're the 8th mission to Jupiter to do what we could to advance our knowledge of it. And I'm very proud of the fact that we were successful at that. And then we launched off across the orbits of Saturn, Uranus, and Neptune on an intercept course for Pluto in summer of 2015. It's a cute little video. The only thing I don't like about it, in fact I hate about it, is that it looks like we missed. We did not miss. So let me tell you a little bit about the Pluto flyby. So here I'm skipping. Basically from Jupiter to Pluto was both Obama administrations went by. And I said we're an inexpensive mission. When Voyager flew through the same part of the solar system, their ground control team had 450 people. And I did New Horizons on less than 50 belly buttons. That counts everybody. That's Glenn Fountain, the project manager, counts him, counts myself, counts the entire science team, the entire engineering team, the entire mission operations control team, and the secretaries. 50 people, a tenth the number of people as Voyager. And some of that was because we had better tools and more automation, just from the passage of time and the improvement in computers. But it was also a lot of innovation. Our spacecraft hibernated a lot of the time. We didn't have to babysit it. But when we got to Pluto, what we found, which we really didn't expect, but it was stunning, was the crowds that showed up at our mission control in Maryland, at Johns Hopkins Applied Physics Lab. This is a picture of those crowds. And if you can look in the back and you see the slide being projected in the bottom left-hand corner, you can see the number 004. That's 4 seconds before the moment of closest approach. And this crowd was going nuts. There were literally 2,000 people in a room that was not built. I don't know how the fire marshal let them in. But it had been a generation since there had been a first mission to a new planet. And people just turned up like it was Woodstock. At least the nerds showed up like it was, Woodstock minus the drugs and the mud, maybe. But inside, behind the scenes, this was my team at the moment, just a few people on my team, but this is the moment they first saw a real detailed image of Pluto. And I love this picture taken from behind. They didn't know they were being, shot. And you can just see how excited they are. Like, wow, this baby is something. We knew going in that Pluto wasn't just the planet itself, but also 1978, the big moon Charon, about the size of the state of Texas, was discovered. And then, starting in 2005, our team discovered 4 outer moons of Pluto, 2 of which are shown in this family portrait. So here you can see Pluto in the lower right. There's Charon, And then this is Nix and Hydra, the two larger of the four small moons. This is a picture of the binary, Pluto-Charon. And the most interesting thing about it, I think, is how different these two objects are, right? Formed together. They've been living together for 4.5 billion years. You know, they say as couples live together over the decades, they get more and more alike. Sometimes they start to look alike. Not these two. Pluto and Charon are completely different. And it turns out it's for an interesting reason in the physics. It's because Pluto is just barely large enough to hold on to the surface volatiles. They don't escape. Charon lost all of its surface volatiles and became just a water ice crust, and wasn't big enough to have a lot of geologic activity for very long. So it represents kind of a relic from the formation days of the solar system, whereas Pluto is bright and colorful and full of dynamics, where the atmosphere and the surface are all interacting, and snows are moving around the surface, and fogs are forming, and all kinds of interesting phenomena like dune fields and volcanoes. I'll show you some of that. This is a close-up of Charon. It's the only image of Charon I'm going to show you. We have very detailed images, but they don't show the whole planet. It's a weird place, no question. It's got the biggest canyon system in the solar system running across its equator. We believe that was formed when Charon's water ice ocean froze, and just the expanding ice cracked it all the way around the circumference. And then it's got a very strange dark polar cap. It's reddish up at the North Pole. Turns out we understand that too. That's actually methane gas escaping from Pluto's atmosphere that runs into Charon and sticks at the pole because it's so cold, 20 Kelvin, 20 degrees above absolute zero. And then the UV sunlight photolyzes that into longer chain hydrocarbons and makes this reddish gunk that's there. And we proved that. We actually went in a laboratory with a cold finger and a vacuum chamber, put some methane and then shined a solar simulator on it, and we got the same result. So the prediction we made was that if there's a red North Pole, there should be a red South Pole. The thing is, right now, Charon's entire southern hemisphere, and Pluto's too, are hidden from us in a long winter darkness. It's the same as why Antarctica is dark, for several months per year. The sun never rises, except Pluto's orbit's very slow, 250 years. This is a 40-year wait to check out that other pole, right? As it turned out, we were smart enough to have made images of Charon in reflected Pluto light, and we can see that pole in those images, and we can see its color, and it's red. So we didn't have to wait the 40 years. This is Pluto, the star of the show. This is a mosaic made of many images and then wrapped onto a sphere so that it gives you the kind of view you would have if you were a human riding on New Horizons. This is part of Pluto's heart. It's a giant nitrogen glacier, and I realize the pointer doesn't show against the white, but this is basically the left side of the heart. It is a nitrogen glacier with a surface area of 1 million square kilometers. So you want to know what 1 million square kilometers is? It's Texas plus New Mexico. And then you can see there's pretty good evidence that it sits in a basin formed by a giant impact, because the whole thing is ringed by mountains that are 15,000 feet high. And those are the characteristic fingerprint of when you get a big impact. The shock waves create these mountain ranges, and we see it all across the solar system. And then the basin filled with all this nitrogen, and the result was the biggest glacier in the solar system. We also studied Pluto's atmosphere. Here's an actual image of the atmosphere backlit by the sun. You can see the hazes in the atmosphere and the layering in the hazes. The altitude that you're seeing up to is about 500,000 feet. This would be orbital altitude if you were on Earth. Satellites orbit at those altitudes. Pluto's atmosphere is very distended. But we also found just fantastic things. I love this, snow caps in the Kuiper Belt. Except this is an area about the size of western Colorado, my home state, and big tall mountains that are about as tall as the Rockies. And you can see the snow caps on them. They're bright white. But we have spectrally fingerprinted that stuff. It's not water ice, it's methane. condensed natural gas, which is a very common material on Pluto's surface, we saw a tremendous variety of terrains. It's one of the most fascinating things about Pluto is that it's as complex as the Earth or Mars, even though it's a little guy. And it really rewrote the textbooks because, basically what we thought we had learned in all the previous exploration is that as you go to smaller bodies, that get simpler and simpler. And Pluto just proved all that. Here's an object that's the size of about the United States, continental United States. And yet its complexity in terms of the range of geologic features rivals Earth and Mars. This is one particular kind of terrain that was seen on Pluto. It's never been seen anywhere else. It's called bladed terrain. These are bladed mountains that are organized over hundreds of kilometers. They're also made of methane ice. It's kind of, the whole thing is like a sci-fi world. A very interesting range of surface ages across the surface. This is an old terrain. You can tell because it's got a lot of craters on it. For those of you that don't understand how we age date things in planetary science, is that we count the craters as a function of size. And it's very analogous. If it was raining out here tonight and I took a piece of paper out in the rain, the longer you leave it in the rain, the more dots. In this case, the more impactors. And when you get to saturation cratering where they're overlapping and work out the numbers, this terrain unit is 4 billion years old. And if you look in the upper right, you can see the context image. The little green box is where it is on Pluto. It's just off to the west of that glacier, Sputnik. But take a look at this. Right next door on the glacier, you can't find a single crater, even in the highest resolution images. And then when you work out that in 1 million square kilometers you don't see one crater, you can get an age recovery from that. It tells you this surface can't be more than a few million years old. That's stunning. Little Pluto is somehow running its geologic engine, like it was just born. It's making features the size of Texas and Oklahoma combined today. There's other signs of activity. This is a topographic map to the east of the glacier. Some of those mountains are 5 and 6 kilometers tall, but if you look where I'm going to point the red arrow, if you can see, it's very hard to see. But anyway, you can see that canyon inside the black triangle. That's a chute, and you can see where an avalanche flowed down that chute and made a circular pool of material where those red arrows are pointed. That's about as big as Greater Denver Metroplex. You don't see a single crater on it because it's young too. That happened yesterday geologically. A lot of things happened yesterday geologically. This is one of Pluto's ice volcanoes. This one's the size of Mauna Loa. How many of you have been to Hawaii, seen Mauna Loa? It's big. It's 150 kilometers across. It's 14,000 feet high. So is this. Doesn't have a single crater on its surface. This was created recently too. Textbooks said you can't have a small planet that's active after 4.5 billion years because the math works out that they'll cool off before that and the geological engine dies. Well, it turns out Pluto doesn't read any textbooks, so it doesn't really care what we think. It just does its thing, and it teaches us that we're wrong, and now we have to scratch our heads and figure out the physics. This is one of my favorite places on Pluto. It is, and you can see the context image. It's up in the mountains, and we believe it's a frozen lake. A lake of liquid nitrogen that froze. We have stereo images that show that this is sitting in a hanging valley. And you can see a shoreline around it. We have topography that shows us it's perfectly flat on the surface. We have spectral fingerprint that shows us it's nitrogen. The thing about that is you can't have liquid nitrogen on Pluto today. There's not enough atmospheric pressure in the phase diagram to get to the triple point where liquids can exist. It takes an atmosphere that's 1,000 times more massive to have that. So we think in all of planetary science is like a one giant CSI episode. We think this is forensic evidence that Pluto had a very thick atmosphere, thicker than Mars's, higher pressure, I mean, in the distant past. Okay, now I have to start this video. Oh, it started. What do you know? When we practiced, it didn't. This is a flyover of Pluto made by New Horizons images, starting at the North Pole. We're going to fly 2,000 kilometers in about 20 seconds. And you can see the craters that let you look down inside the surface and see layering. You can see dust devil tracks from tornadoes or something like that that have gone across the surface. And then we're going to go up on some badlands and then into big mountain blocks. These are all made of water ice with a nitrogen coating. And you see the six mile scale bar there, so you get a feel for these things. And then off onto the glacier with dune fields and these interesting geological cellular patterns that indicate the glacier is convecting. What a crazy place Pluto is. That's not good enough for New Horizons, though. Our job was to go on to explore the Kuiper Belt, and we will be in the Kuiper Belt until the late 2020s. And so very shortly before the Pluto flyby in 2014, we used the Hubble Space Telescope and found some objects in the Kuiper Belt that we could reach by diverting the spacecraft trajectory within the amount of fuel that we have. And we picked one of those. Actually, I picked the one, and I picked it very simply because we didn't know anything about any of them, so you can't choose based upon this one's more interesting than that one. I picked the one that took the least fuel so that we could hoard as much remaining fuel as we could for maybe a second flyby. And we're still looking for that target, and I can tell you about that in the Q&A if somebody's interested. But anyway, we went off into the much further reaches of the solar system, still traveling 1 million kilometers per day, every day. And we intercepted a little tiny planetesimal, 33 kilometers in length. So like the size of, a major metropolitan area. Let me give you a feeling for the difference in size between Pluto and the flyby target, the planetesimal, which we named Arakoth. And so what I'm going to do in this, and you got to watch because it's a 5-second video, and I'm only going to play it once. We're going to zoom up on Pluto, and then we're going to put Arakoth for scale. Where's the little bar? There it is. Bingo. Here we go. Zoom up. Mountains. There you go. And we had to hunt that sucker down in the dark, going 40,000 miles an hour while it's going 4,000 miles an hour and not miss. And we'd only known about it since 2014. The 5 years that we knew about it represent 1% of its orbit. And the team of people that did this just did it so professionally and so excellently. Couldn't believe it. And this is the result at 3 in the morning, first image to the ground of Arakoth. Here's this wild planetesimal thingy, not at all looked like something in the asteroid belt, right? It sort of looks like an upside down snowman, right? And this is just a nerd party here at 3 a.m., right? This is in our geology room. This is what it looks like in color. Again, about 20 miles long or about 33 kilometers, same thing. And what it is a type of object we call a contact binary. It's really two objects that are stuck together. It has lots of interesting geology on it, but look at its shape, how flattened it is. Can you see that in the third dimension, these are images from New Horizons from different angles. And so you can see it's more like a pancake in the larger lobe, and even the smaller lobe is also very compressed in the third dimension. And if you look at across the surface, you don't see any signs of violence. There are no fracture patterns, for example. When these two things came together, they clearly came together gently, and we simulate that in computers, and it turns out that they came together at walking speed. Otherwise, we would see evidence of damage. And that's incredible because it revolutionized our knowledge of how things form. For 50 years, there have been two theories that were competing about how planetesimals form. One was they form in different orbits around the sun. They collide together and stick and build up larger and larger things, from rocks to boulders to building-sized things to planetesimals. And there, the collisions are typically at hundreds of meters per second. And the other theory is that all across the whole solar nebula, little pockets were collapsing. And because they were only made of things close to them, the collapses take place at these meter per second or a few meter per second speeds. And from a whole range of scientific evidence, about this object Erkoth, its story only points to the second theory, and it rules out high-speed collisions in the first theory. And people have been debating this and making better and better models for 50 years. And we settled it one day by getting a chance to see Erkoth, a well-preserved planetesimal, up close and personal. Okay, so this evening, I've given you a bit of an overview of New Horizons. David Grinspan and I wrote a book called Chasing New Horizons. It's about 250 pages of nerdliness. It's done pretty nice in the bookstores because my mother goes and buys copies every week for her friends. But if you're interested in learning more about it, there's an audio book. David does the narration of 90% of it because I'm not good at that. And you can also buy it on Amazon, or if you want to, from Antigone Books in Tucson. I don't know if you guys know anybody from Tucson? Okay, Antigone is the oldest bookstore in Tucson. And my daughter Kate bought that bookstore in 2018, so that's why I'm advertising. Buy it from Kate's bookstore. So our mission continues. The spacecraft is very, very healthy. Nothing is broken. We've been 17 years since launch. All the prime and all the backup systems work perfectly. All the instruments perform perfectly. We have enough power and fuel and communications range to run this thing to the year 2050. I don't know if I'll be operating in 2050, but New Horizons probably will. And it continues to move at these very high speeds. So like Voyager, it's going to leave the heliosphere out into the interstellar medium somewhere in the late 2030s or around 2040, which is not so far away anymore. But we will leave the Kuiper belt somewhere around 2027 or 2028. The spacecraft is being used every week to do scientific observations. We've observed, besides Erkoth now, 36 other Kuiper belt objects and dwarf planets. And we continue to do that. Eventually it'll become a different kind of mission because there won't be anything left to fly by. We're still looking for that last flyby target. Very hard problem because we're looking at 29th magnitude. And this crowd knows how hard that is. And if it's not hard enough to get to 29th, the direction of our flight is towards Sagittarius, the galactic center. So try and find 29th magnitude objects moving against these obliterated background fields of stars. That's our task, and that's why it takes a long time. And I'm down to 1/8 of a tank of gas. So we only have so much gas to divert the trajectory. We got to find something that's going to fly very close to us so we get a close flyby. Don't know how that's going to turn out. We might not find it. We've got the biggest telescopes, the best people, the best cameras in the world. We might get lucky and we might not, and you'll just have to stay tuned. But that's the story of New Horizons. And thanks for having me at TSB. And why don't we have Q&A? I'm going to start in the front, just because you're right there. He asked, I was told, repeat the question for the online listeners. He asked, how long do you have to make observations? It depends on the size of the object. For Erkoth, it only became resolved more than 1 pixel, slightly more than 48 hours before we got there. So we had 2 days to do everything. For Pluto, that was 4 months. Oh, right there. Okay, so the question is, has Pluto ever had a close encounter with Neptune that might affect its geology? That's a really good question, because if you look at a map of the solar system with the orbits of the planets, and I think most people here probably know, Pluto crosses inside of Neptune's orbit every time it comes close to the sun. Not very close, but its closest point, called perihelion. And as it turns out, though, and this was discovered in the 1960s, that Pluto and Neptune are in a gravitational resonance that keeps them from ever getting close to one another. Every time Pluto crosses inside of Neptune's orbit, Neptune is way around the other side of the sun. And it just works like a Swiss watch. And it's been going on for billions of years. So no is the answer. Pluto never gets close to Neptune. The closest, in fact, it never gets closer to Neptune than Uranus gets to the Earth. So it's a big solar system. Right. The man with the mustache. So he asked, what is the communications time lag back when we went by Pluto? How has it changed? What is it now? So it's just a trick of arithmetic. I mean, it's just lucky. But New Horizons, at the speed it's going, it works out that every year, the round trip light time, the time it takes for a signal to go from the Earth to the spacecraft and then back, increases by 1 hour. We got to Pluto 9 years after launch. It was a 9-hour round trip light time. Now we're further out. We're 17 years from launch. It takes about 17 hours to do the round trip. And it gets longer every year, which means that for a fixed hour communication system, our data rates drop every year a little bit. Other questions? Blue shirt, please. Yep. The dunes. So he asked if the dunes are static or if they move. And we don't know, because we were only there in July of 2015, and they weren't moving that fast that we would see it in a matter of days. Even dune fields that are active on the Earth and Mars take a long time compared to a couple days to move. What it would take to determine that is a Pluto orbiter. And there's a lot of interest in going back to Pluto, but this time to stay with a even more sophisticated spacecraft that would orbit the system and check everything out that we only glimpsed. But that mission is for my kids' generation. Any other questions? Yes, sir. Yeah. So he asked whether the season that Pluto was experiencing was a factor in how we designed a trajectory. And the answer is no. We actually designed a trajectory to get to Pluto as quickly as possible. And that means I can tell you in more detail later, but the orbital mechanics is that you don't want Pluto to be out of the plane of the solar system. You want it to be right in the plane so that all of the rocket's propulsive capability goes to forward speed instead of plane change. So we actually intercepted Pluto just as it crossed the plane for the first time in over a century, a half orbit. But we did get to pick other things, and we picked, for example, which hemisphere to fly by. Pluto rotates in 6.4 days. New Horizons goes by on 1 day. So we got to pick not just the altitude of the flyby, but also which chunk of terrain we wanted to see. I think we hit the jackpot with we flew right over the heart, over Sputnik Planitia. And of course, we didn't know we would get quite so lucky, but we knew that there was a big, interesting blob of terrain there in the Hubble images. So we targeted for that. Yes, sir. Don't women in this audience ask questions? Right, okay, so the question is 9 years to traverse the solar system, what's a day in the life like? Well, first, you're right. Every person that works on New Horizons in flight works on it part-time. We just don't have the budget, and so everybody's on 2 or 3 missions at once. Now, the people that spend the most time on New Horizons are the flight controllers and mission control. But for the science team and the engineering team and the management team and the public affairs folks, we're not on the computer's console every day. But remember, Voyager took 450 people to plan those flybys of Jupiter, Saturn, Uranus, and Neptune, we had 50 people. And so we had to do all the same work. And it took us 9 years to do it. We started early, and we wanted to put it in a box and get it all tested and ready to go. And then we started finding more and more moons, and then we realized, what if there are a lot of little tiny moons and there are hazards out there? What if we discover them late on approach? So we actually planned other flybys that we could divert to, some at closer distance, some at farther distance. And then we had to do all the same loving care of planning that entire flyby over and over again for different aim points, so that we would have options if Pluto turned out to have a ring system or other kinds of debris. So we were really busy, and I remember Alice Bowman, who's our mission operations manager, sort of the equivalent of a flight director in Apollo or the space shuttle or something. The heart of she's the head of mission control. Said it was a 9-year sprint. Yes. Yeah, that's a good question. Could we figure out the density of Pluto or other things from looking at slight perturbations as we went by? And the answer is we could, but to get the density, you have to know two things. You have to know the mass, and then you have to know the volume. What New Horizons did was nail the volume. By taking images from different angles, we could get down to the kilometer exactly how big Pluto is and how distorted from a sphere it is. It turns out it's not, even at the 1 kilometer level. It's perfectly spherical. But we already knew the mass because from Kepler's laws and just the discovery of the big moon Charon, you could figure out the mass. So New Horizons didn't really contribute to the mass. It was already known. We added the exact volume. So as a result, we got an exact density, and it works out to be a 40-60 mixture of ice and rock. It's mostly a rocky planet, despite the fact that we think of it as an icy planet, because that's what's up on the surface. It's mostly a rocky planet. Yes? We had to put in a lot of correction terms. The solar wind, the question was, do you have to put in a lot of the fine details and the subtle effects in order to target the spacecraft? And I have to tell, but let me give you an idea of the targeting. So in order to accomplish all the scientific objectives, we figured out mathematically that we had to fly through one small window of space that was 40 by 60 kilometers, which is big. It's like the size of a county in East Texas. But when you're aiming from 3 billion miles away, that's very tiny. And somebody clever said and they worked the math out. It's just an arithmetic problem. It's making a golf shot hole-in-one from across the continent of North America, right? But the better part, my favorite part is, the way New Horizons works, we also had to tell it when we would arrive. So it would know from calculations where each moon was as it was going by. And when we worked out how closely you have to center all the images, it worked out that we had to arrive after 9.5 years within 450 seconds, is 9 minutes, of the pre-planned time. Or you would have seen a lot of pictures that were like half of Pluto, or a little sliver of Pluto, right? It would have been embarrassing, to say the least, right? So we had to get it down to within 450 seconds. Yesterday, I flew to El Paso to come here from Denver, and United Airlines could not get me there within 9 minutes of the appointed time. But we actually showed up 86 seconds off target, and we were early, 86 seconds early. Okay, I'm being told only 2 more questions, but I'm sticking around for the evening. I'm just looking to see if women are raising their hands. Okay, all right. Oh, is there somebody hidden? Yes, sir. What is the transmitter power? 15 watts. Yep. You know, like a little 15-watt light bulb? Yeah, 15 watts. Yeah. So it's actually, that doesn't count as a second question, okay? We have two transmitters. For those of you who know something about communications and electrical engineering, the two communication systems operate in a reverse polarization. One is left circularly polarized, the other is right circularly polarized. And so we can do them both at once and double our data rates that way. But it's a very small amount of power transmitting over a very large distance, which is why the data rates are like old 80s modems, because in order to pick that signal up, even from dishes the size of a football field on the earth, requires slow data rates of a few thousand bits per second. Okay, last question right here, first row.
Do you have any potential targets?
We don't yet. We're looking hard. It's about, if you work out the math, it's about 16 times harder than Aircoth, which took 4 years to find. So maybe stay tuned. But I say this every time I give a talk. We were sent to make the first exploration of the Pluto system and the first exploration of a Kuiper belt object. We've checked all the boxes. This will be the icing on the cake. Nobody wants another flyby more than my team. And we're looking under every rock. But we're going to leave the Kuiper belt in 2027 or 2028, so that the time is getting short now. We will see. If it can be found, we will find it. Okay, that's the last question. I'm told that's it. Thank you.
Dr. Stern, in your illustrious career, you've received many honors, but none, I think, more valuable than this. I'd like to, the 2023 Certificate of Merit. Thank you very, very much. Okay, everyone, we've got a few housekeeping details to take care of here. Also, as Dr. Stern said, that he is going to be around in the evening, so if you find him and you have any more questions, I'm sorry we had to kind of move on. He will be happy to answer further questions. Okay, if you have not, this is your second and final call for boarding. If you want to enter the door prize drawing, please find Amelia. Amelia, are you out there? Oh, okay. Ann Atkins, she has the basket for the drawing, so please make sure that you put your half. Okay, put your half of your drawing ticket into the basket so that you may be present to win. So you can't just drop and run. We did something new this year at TSP, the poster sessions, and we had 3 very, very fine entrants. One by our own Michaela Waller, the recipient of this year's Lone Stargazer Award on tracking helium. It is still currently displayed. I invite you to take a look at that. We had a poster presentation by Kelly Miller on the total solar eclipse, and we had one from Christy Walton on quasar, which is also still back there. There was an invitation for voting, and I am pleased to announce that the winner of the poster session for 2023 is Christy Walton for quasar. That's the good news, Christy. Please stand up. The bad news, Christy, is that unfortunately we ran out of certificates, so we're going to have to send you yours. Also, we had an art exhibition this year. We have exhibited art in the past, and we've had some very fine contributions by Ann Saker, my sister, and by Christy also. Christy's paintings are are still in the back over by the astrophotography display, and my sister has generously donated her star trays, a pair of them, for tonight's door prize drawing. And you didn't offer them to me, I'd have paid you for them. So thank you very much. We do encourage, we would like to encourage greater participation next year, so all you budding artists out there and whatever media that you enjoy, please consider bringing some of your art next year and telling us about your inspirations and the choice of media that you used. We'd love to see it. This year, the Astrophotography Award, we had three entrants. They're absolutely stunning back. They are still on display in the back. Ken Levin displayed two images, one of M53 and one of M51. They're just really gorgeous and stunning. And Steve Grimsley put on display an image of the Witch Head Nebula. That's a very tough object to image. I've tried and have not been able to get anything that was remotely usable. So I salute all three of the images, the two imagers who submitted them. The winner of the astrophotography contest, the people have voted, and the winner is Steve Grimley for his image of the Witch Head Nebula. Is Steve here? There, Steve, wonderful job. And once again, a very valuable recognition with a TSP Certificate of Merit. Although some, like Larry, would wallpaper his room with them. I suppose it's just all supply and demand, right? Okay. At this point, I think I'm going to turn the microphone over to Larry for a couple of minutes. Okay?
2 minutes. I just want to talk a minute about the Advanced Observing Program. This year, I handed out only 13 awards or pins, and you guys know why. The night sky that we've had wasn't exactly pristine. I won't be here tomorrow, but those of you that know Steve and Amelia Goldberg, and I don't know where you are, would you stand up? In the back. They're my observing partners in Houston, and I'm going to give them some pins, so if it clears up tonight, you folks can see them tomorrow for an advanced observing pin. And I'm going to change the rules a little bit. Instead of having to see things within these galaxies or these nebula or whatever, all you have to do is just see the galaxy. Just see what's there. If you can see what's in it, that's great. But just because of the weather, just see the object, log it, go see Steve and Amelia, and you get an advanced observing pin. So I want to thank you guys for participating. Everybody drive carefully going home, and we'll see you next year. Thank you.
Thank you, Larry. That's very generous. I want you to know it was not for lack of trying. Next, I have Craig Colbert, who is going to announce the winners of the ATM contest. This year, I was on the selection committee, and I will tell you, we had a number of extremely fine entrants. This has been a real year for ATM, and I suppose a lot of those ideas were kind of percolating during the pandemic, and they burst forth in a profusion of innovation and industry. So it was very difficult. It was very difficult to pick a winner, but
We obsessed over it.
he had to. So without further ado, here's Craig Colbert with the winner of the ATM contest. Craig?
Yeah, we've got 2 runner-ups and the grand prize winner. Chris, did his name wrong earlier. Chris Hill. There you go. If you could come on up, I've got your. He was putting his scope together here at TSP, and it was First Light here as well? No, okay, we can blame Jonathan on that. And there you go. Thank you very much. He built a, well, why don't you give us a little, tell us a little bit.
Sure. So, built a mostly 3D printed 8-inch F4 Dob with the Go-To system. The scope itself was designed by another person that I suspect we'll probably hear from tonight. The Go-To system I built myself using OnStep. So.
Thank you. Very good. Brian Lippincott. I mean, who would have guessed? Brian, you here? He's the second runner-up. He built a matching set, of course. You built a matching set, telescope, chair, and a box that holds his eyepieces. Oh, it's an amazing thing to see. And of course, Brian, his mantra is, over-engineering is underrated. And if you've ever seen any of his stuff, you know what I'm talking about. Thank you, Brian. Thank you. Thanks, and our grand prize winner is Jonathan Kistner. He's a 3D print master. We should give an award to the 3D printer. I'll tell you that the field was filled with 3D printed stuff for astronomy. It's amazing. Here you go, Jonathan. He built, actually three amazing one little scope, a grab and go. Is that the one that's on, that's in Sky and Telescope? Or is the other one?
So the one in Sky and Telescope is, the one in Sky and Telescope is 114 f8. This is almost the exact same thing, but it's f3.9, just half length. Wide field.
You won it for the big 16.
16?
Yeah. You wouldn't believe this thing. You collimate it using your poles. You turn the pole, it moves, it either spreads out or it contracts, and that's how you don't have to bend over. You don't have to have two people.
You can collimate it with a star test.
There you go. And let's see what else was there in there. Oh, the secondary. No spider. It just floats. Now, how did he do that? Piano wire and frets. And just an amazing piece of work. Thank you very much.
Thank you.
And now that you know that you can print 3D parts for your astronomy stuff, let's bring more of this stuff here next year. Thank you.
Thank you, Craig, for heading up the committee and making the tough choices. Now, those of you who have come to TSP for any length of time or read the website knows that TSP has several awards that it gives out every year. Last night we awarded Michaela Waller the Lone Stargazer Award. Tonight we are going to award the Omega Centauri Award. It is bestowed on the person whose notable efforts have increased public awareness and or knowledge of astronomy and or amateur astronomy. This seemed to be a fairly easy choice. Her ongoing and successful efforts at the promotion of astronomy as past president of the Houston Astronomical Society. She coordinated the Women's SIG, encouraging women's participation in astronomy and space sciences. As field trip and observing chair, she encouraged usage of the club's dark skies site. And as a current TSP board member, she has donated generously her time and expertise in helping TSP carry out its mission, which is the Texas Star Party and the promotion of astronomy and space sciences in general. Texas Star Party, Inc. is proud to announce that the 2023 Omega Centauri Award goes to Renee Gaddaly. Is Renee here? There you are. Now, Renee, oh,
So that's what these things look like?
that's what that. Even more valuable than the certificate of merit, because this is in recognition of a very well-lived dedication to promoting what we all love very much, which is the enjoyment of the night sky and space science. So we thank you very much, and in recognition for your service, please accept that with our generous thanks. Okay, everyone, this is your absolute final last boarding call for the door prize Great Texas Giveaway Part 2. So if you haven't dropped your ticket, this is it. Can we have the sacrificial victims, the tickets brought forward? Oh, they're already here, thank you. I have an assistant I would like to call on to come forward right now. Maybe two? Come right on up. How are you tonight?
My name's Madison.
And what town are you from?
Sealy, Texas.
Very nice. Oh, they have, okay, better put them in there. There you go, okay. Okay, the doors are closed. Okay, we're pulling away from the terminal now. No more, no, we're closed. So what I'd like you to do is give this a good shake. Give this a good shake. And we are now going to begin the Great Texas Giveaway, Part 2. Let's see here. What goodies shall we do? Let's start out with this. This is from the McDonald Observatory. This is from McDonald Observatory. I think they're trying to make nice after canceling the 36-inch telescope sessions. So we're very grateful for that. Very grateful for it. It's called Dear Visitor, Voices of McDonald Observatory by Karen Stewart Wingate. Also comes with 2 additional issues of Stardate, the McDonald Observatory magazine. Why don't you go ahead and put that there, and you'll draw the ticket, okay? And that's it. And the winner is Douglas D. Hoople, Bellevue, Washington. Are you here? Okay. Hey, how are you? Oh, very good. Okay. What we'll need you to do is, okay. Our next, again, from McDonald Observatory. This is the West Texas Time Machine, Creating the Hobby Eberly Telescope, Photographs and Narrative by Thomas A. Sebring. Also comes with 2 editions of Stardate magazine for your reading pleasure. And the winner is, we have a Cinderella, blank. Number 317-83229. Oh, look at you. Okay. Which one? Oh, okay, that's for. Thank you. Congratulations. Wait a minute. Hold it. Jose. No, are they doing it in the back now? Yeah. Okay. Very good. Okay, the next one, once again, from McDonald Observatory. Very nice hardbound book, Big and Bright, A History of the McDonald Observatory by David S. Evans and J. Doral Mulholland. Along comes with 2 issues of Stardate magazine Another blank? Okay, no problem. This one goes to the holder of ticket number 317-83295. 317-83295. Any takers? Well, going once, going twice. You know it. Let's try again.
These are one prize.
Oh, okay, that's fine. That's fine, but from... Okay, we'll try again now for Big and Bright. Ticket number, oh wait, we do have a name on. We do have a name. Chris Hildreth of Elgin, Texas. Chris, oh, there we go. Oh, he's cleaning up on us. Gotcha, yep, I wrote that, I know that. All right, now for something more practical at the eyepiece, at the telescope, we have from Agena Astro, an 824 millimeter zoom eyepiece, 1 1/4 inch format. Not bad, eh? And no name on the back, but ticket number 317-83135. 317-83135. Are you our lucky winner?
Oh yeah, I got it.
And your name?
Joe.
Joe
Kuttner.
Kuttner. Joe Kuttner. Where are you from, Joe? Hey.
Alabama, Huntsville.
Huntsville, Alabama, Rocket City. All right, man. Okay, correct me if I'm wrong. Why is this still up here? Did I not give this away? All right, let's draw another ticket for that. Back to Big and Bright. Am I eligible to win this? Okay. But I didn't. Lon McCroskey from Mission Hills, not sure, Mission Hills, Kansas. Mission Hills, Kansas. Lon McCroskey. Is he in the house? Going once? Going twice? Man, nobody, I can't give this thing away. One more time. Okay, if I don't give it away this time, I'm keeping it, okay? 317-83015. No name. Okay, all right. Yeah. Congratulations, you got my book. I'm not going to have to buy that back somehow. And now we have another book, The Observer's Sky Atlas, 500 Best Deep Sky Objects with Charts and Images. This has to be really good. I didn't get to take a look at it, so a slight pause while I read this, okay? Okay, and this very lovely reference work goes to Rebecca Brewer. Is Rebecca in the house? Oh, good. Congratulations. Oh, this came out of the envelope. Okay, great. All right, imagers, pay attention here. Okay, this is possibly the most important element of your imaging experience is the software. And I know people swear by PixInsight, but it has a learning curve that is probably an acute angle from where you stand. Therefore, masters of PixInsight have generously donated one live or recorded workshop, $35 value. So this could be very important in helping you get the very best out of your telescope time and your images. And the winner is Aurora Jacobson. Going once, going twice. All right, Aurora. Let's hope she's not an imager. Okay, the next possible beneficiary of this bounty of knowledge and information on image processing is Madison Withrow. If you don't have a camera, hang around. Maybe you'll get this. We've got an opportunity for you to get a camera to start imaging. That's great. Okay, next up. Next up, from Fred Tenney of Gazer Aids. Now, this guy is really, really, really important. He sells us the red filters for our screens so that everybody who uses one can be in compliance with dark out regs. So, Fred, are you in the house? There you are. Thank you so much. Thank you for supporting TSP. Thank you for being here as one of our vendors. So everybody, Fred's information is at gazeraids.com. If you need anything like that, I'm sure Fred can make arrangements to get you whatever you need here or there to make sure you do not disturb your neighbors when you are imaging or, playing Candy Crush or something on the phone. Okay, our winner is another, what's that? Oh, but thank you for reminding me. I know. It's a mystery. You'll have to win it to find out. No, seriously, it's a Rigel Systems Quick Finder. It's a vertical, it looks like the monolith of reflex sights. The Telrad kind of lies flat, the Rigel is straight up. And the Rigel, Telrad, battle royale will be on the tennis courts after this is over with. The winner is no name, but number 317-830-76. 83076. Roy, you again?
This is 2 prizes, okay?
Okay.
One from the Dice Star. And one
Oh, okay.
books, okay?
Very good. Excellent. We have a combination prize here from 2 different. Where's Roy? Oh, there you go. Go see Matt. Okay, we need a few pints of your blood. We have a combination prize here from Daystar, Universal Solar Lens Filter Kit, and a copy of their catalog. This is what I call your solar eclipse preparation kit, and the Night Sky Almanac for 2023 by Nicole Mortellaro from Firefly Books. That looks like it could be good. And the winner is a blank name, ticket number 317-831-9er8. Who's got that? Who's got 9er8? Here we go. No, we'll just go with. I have just been advised of a late entry. It's not? Well, I didn't tag this. Okay.
It's in 101.
Oh, is it? Okay, well then we better show it. Look at this. This is a blanket. Oh, look at that. Isn't that beautiful? This is an astronomy blanket from Madison's family. Is this your grandmother, right, who did this?
My grandpa, he made the picture, and then my grandma helped him put it like on a blanket. They sent it to a company and they put it on a blanket.
Isn't that beautiful? Thank you very much. Thank you very, very much. It's an excellent prize. Keeps you nice and warm at the eyepiece on a cold night. And the winner of this beautiful blanket is Terry Jones. Is Terry here? There he is. Okay, there we are. Okay, we have two. These are two separate ones. Okay, rather than try to break this up into, I'll give one away now and one later. We're going to give both of these away one at a time right now. These are from Hubble Optics. They are artificial stars. They are very good for collimating your telescope when, on a night like this, we have no stars to use, no natural stars. So let's draw one, Madison, for the first one. Whoops. Ah. This looks like Richard Kluh from Falls Church, Virginia. How do you pronounce that? Oh, Club? Oh, congratulations. Oh, Klein. Oh. All right, leave it to me to overcomplicate something like that. And the second one goes to our very own Kelly Miller. Kelly, are you here? There you are. Congratulations.
Prizes again to one individual.
And here we go again with another combination prize from Daystar. The Universal Solar Lens Filters, aka your Total Solar Eclipse Preparation Kit. And from Celestron, a lens pen. Very good for cleaning off the eyepieces without scratching the glass. Very important. And the winner is Cody Jacobson. Cody, are you here? Going once. Going twice. Thank you. Let's try again. No. No, it's not me. Where's Flash Spieler? Ed? There you are. This will help you get ready for the solar eclipse and keep your eyepieces nice and clean.
This is from Infinities. They just handed it to us.
Oh, okay.
My name is pronounced Flosspolar, or if you're an American, you can say Flasspolar. And if that confuses you, I am Amy Poehler with Flass.
Thank you, Ed. Thank you very much for that. From another one of our vendors, Infinities, who also, I believe, is our the vendor who was over at the pavilion. This is looks like a very beautiful design, a sailing ship with a moon in the background on a beautiful starlit night on the ocean sea. Size large. What's that? Hey. No name, ticket number 317-830-31. 83031. Going once. Going twice. Let's try again, shall we? That looks like my handwriting. No, it doesn't. 317-83002. Where's Agent 002 when we need him, right? Or her, for that matter. Anybody? Check your number. Going once? Going twice? Must be present to win. Okay, Curtis Hoffman from the 603. Oh, okay. Also, I believe this is also from Infinities as well. Astronomy Universe. That's kind of, boy, what an old and ancient institution that is. What size is that? Also size large. Okay, no name on this one. Ticket number 317-83201. 3201. Boy, I tell you, I can't give this stuff away. Going once, going twice. Okay, this one is Joel Brewer. Joel, are you around? Okay, this is also from Infinities. Please, I don't know if he's packed up yet, but if he has, go to his website, look at his t-shirts, buy some t-shirts. They're nice. This one is the sun, front and back. In case you didn't know, that's the sun. You can, and when you wear that and walk around, you will be promoting astronomy and space sciences to everyone who does not know what the sun is. Hey, don't laugh, I wouldn't put it past a whole lot of. And this t-shirt is size XL and goes to Dave Wickham of San Antonio. All right, David. That's beautiful. A long sleeve tee. This is really handy at TSP. XL. Our solar system, you are here. That's the only thing it's missing. This one goes to Kent. Where's Kent? Kent Francis. My neighbor. Okay. Oh, okay. We're going to do both. Oh, terrific. Okay, we have another double whammy here. Our double whammy prize is another total solar eclipse preparation package from Daystar and the Backyard Astronomer's Guide, 4th edition by Dickinson and Dyer. And this looks pretty substantial. I swear you could probably use this as a counterweight if you're not actually using it. Okay, no name on this one. Ticket number 317-83142. 83142. Oh, there we have a winner.
I'll hold these, but these are your sister's plans.
Let me have one.
Okay, do not drop it. Don't drop
Are you kidding me? I got to ride home with her. She'll kill me. See, she's not paying. Good thing she's not paying attention. This is an example of the potter's work. Notice the very fine shape, the attention to detail on the rests, and of course the glazing. A very lovely astronomical themed ceramic tray, a pair of them by my big sister Ann Saker. This one does not have a name on it, but it is number 317-83206. 3206. Anybody? Maybe I better check my ticket first here before I give these away to somebody else who may not appreciate them the way I do. I don't even know my ticket. No, that's not mine. Doggone it. All right, going once. 3206, going twice. Must be present to win. Karen Botham. Oh, I can tell they're going to a good home, Ann. I can tell they're going to a good home. Isn't that great? All right, next, by Craig Crossan and Will Tyrion. Everybody knows who Will Tyrion is. I don't know who Craig is, but he's got to be good if Will's working with him. Binocular Astronomy, second edition, and includes Will Tyrion's superb Bright Star Atlas. Take that, binocular list from hell. This goes to Reed Ship. I don't know, where is that? Okay. Now, this is something that is very near and dear to my heart. He was here last year, gave a wonderful talk, went out on the field and helped an attendee with his telescope. This is a certificate for a set of Bob's knobs. And I know that Bob has been a long time supporter of TSP. I have a set of his knobs myself. They are beautiful, they work. If you buy a set of knobs, they will fit the scope you buy it for. And if you had your scope here, Bob would install them for you at no extra charge. So, I mean, you can't say enough about the guy. He's really great, and so are his products. And this one goes to our very own Ann Adkins. Ann wins a pair of Bob's knobs. He's always wanted a set of Bob's knobs. From Software Bisque, the maker of the Paramount ME mount, the Sky software, and lots of other stuff. Congratulations, you have won the Sky Imaging Edition. Wow, this is a very good prize if you like to control your telescope by computer. This is a one-year, well, it did say it was a one-year subscription to Photoshop and Lightroom software, but no, this is infinitely more useful. This is the Sky Imaging Edition. And I don't know what he's charging. I don't know what Steve's charging for it these days, but I'm still using version 5. He asked me why I'm starving his children by not upgrading. I said, because it works. Chris Bebrin. Did I pronounce that right? Ticket number 82993. That looks like Chris. I don't know, like maybe I'm not reading this well. From Colleyville, Texas. Going once, going twice. Must be present to win. All right, let's try again here. We do have a name, Nick Rotundo. Nick, one of our presenters. Thank you, Nick. From Celestron, we had several of these in the first half of the Great Texas Giveaway. Celestron Power Tank Rechargeable Flashlight. This is very handy out in the field as well. And this one goes to Murphy, P. Murphy. Jeez, I can hardly read that. 83181. Okay. Uyakacha. Now, guys, I saw something this week that I hadn't seen here in a long time. Dew on the corrector plate. It happens even here. Now, my friend Joe Golias, whom I've known for 20 plus years, formerly of Cleveland, Ohio, now of Dripping Springs, Texas. His company's AstraZap. He makes at manufacturers all kinds of systems for keeping that doggone water off of your objective and your eyepieces and anything else. AstraZap. $50 gift certificate. There's a lot of stuff you can buy on his site that will keep your optics clean and dry all night long for $50. And this one goes to ticket number 83334. Is that, oh, there you go, X. Now we need to get you a telescope to put it on. Okay. From David Ho of Hotech, it's a 2-inch SCA laser collimator, class 2, wavelength 650 nanometers. Comes in its own carrying case and a 2-inch to 1 1/4-inch adapter. It's a very nice piece of equipment for collimating your scope. Then the winner of this very fine instrument is Nathan Day. Is Nathan Day here? There he is. Congratulations. Camera Concepts. I am going to have to get a hold of Jeff and tell him he needs to bring these things here in person. Hopefully. Hopefully we can get Jeff back here next year. Jeff was a longtime attendee and a vendor here. He would bring in bins of stuff, a lot of which was extremely obscure stuff. So you'd go in there and say, you have this. More often than not, he would have it. Saved many a TSP for a lot of attendees. So hopefully we can get him back. And I call upon you to spam him mercilessly about coming back here. $100 gift card from Camera Concepts. And the winner of this is Ginger Connell of Dayton, Ohio. Where's Ginger? This is going back to the Buckeye State. Another live or recorded workshop session from Masters of Pix Insight. Oh, okay, yeah, there you go, thank you. The winner of this very fine font of knowledge is 83236. 83236. All right, here we go. Are you an imager? Find someone who is and sell it to them at a discount, right? Excellent. From Celestron, one of our vendors here, please patronize them at your earliest convenience and do it often. An 18mm Ultima Edge eyepiece. So this is E-Y-P-I-E-C-E. Yes, I know how to spell. A slight pause while I correct my spelling. That's what happens when you get, 3 hours of sleep. Your brain turns to mush, but it's a pleasant place for it to happen. Next, this goes to Jeffrey Bennett. Jeffrey Bennett, all right. Okay, Jeff just got the 18mm. We have, again from Celestron, the 15mm Ultima Edge eyepiece. The little brother to that, or big brother, depending on whether you're judging by magnification or numbers. This goes to Steve Grimsley of Burlington, Vermont. All the way from Vermont. Here we go. From Telegizmos, a gift certificate of $50 good toward any Telegizmos scope cover. These are fantastic. They are really fine, a really fine addition, especially here if you leave your telescope out. You have a cover like this, it's going to be very nice, very nicely protected. Carl Jones. Carl, are you out there? Are you out there in TSP land? No? Going once, going twice. Must be present to win. Because postage and handling is not included. Gary Dowdle of Fort Davis. There you are, Gary. You'll need that here. From Celestron, one of our longtime supporters and vendors, Another power tank flashlight. Very good for seeing in the dark. Very important around here. Madison, thank you. We have Lloyd. Oh, I can't read that. Lloyd. Can you read that?
Mashbrook? What? Oh, Lashbrook. Lashbrook.
Oh, Lashbrook, okay. Lloyd, congratulations. Okay, another power tank flashlight from Celestron. Thank you very much, Celestron. We really appreciate it. Come back next year. Ticket number 83027. 83027. And who is that? Well, I guess I'll never know. All I know is it's going to a good home. Another $50 certificate from my friend Joe Golias of AstroZap. Fred, where are you, Fred? Fred Lucen. There you go. Oh, yeah, look at this.
They're the same thing.
Yeah.
And we're going to give them the two tickets.
Right. We have the supersized Celestron power tank, portable power pack. Is this the Pro model? No, the portable power tank. Okay. We need another one. Okay, one goes to Gary Blair. Is Gary around? Gary? Going once? Must be present to win. I'm sorry for his emergency. I hope it's not, really bad. Thank you. Okay, first one to we'll try again on the first one. Stephen Barrett, Georgetown, Texas. He needs to see the light that Ohio State is cool. The second one goes to Mark Stahl. Mark Stahl, number 83245. Going once, going twice. Must be present to win. Boy, we are emptying out this bucket, aren't we? That means that everybody here, your odds are dramatically increasing here, so hang in us, because we still got some great grand prizes coming up here. 83095. From Precise Parts. I don't know if you're familiar with them, but I don't know if they 3D print, but they definitely will cut. Well, you can design a connector online and they will cut it for you. $100 value for a custom adapter designed online. This is $100 toward the purchase of a custom adapter you design online. It is a kind of a neat thing to do. I looked at it once. Jerry Gardner. Jerry Gardner. Going once. Going twice. Must be present to win. Mark, I can't read that. Mark Sitch. Mark Sitch. 83239. Okay, going once, going twice. Must be present to win. Oh, too bad. Okay, Homer
Homer back there, can't be many Homers.
It's not Simpson, so forget that. Don't even ask. 83262. What, Homer? What's your last name? Vasquez. Okay. I don't know why I couldn't read it. Okay. Oh, we have two Power Tank Pros. Aren't they beautiful, folks? 17 hours of power for your telescope, car battery adapter, 2 USB ports. It's really deluxe. Okay, the first one goes to Fred Miller. Where's Fred? I know I saw him here somewhere. Where is he? There he is. And the next one goes to Andy Overman. Is Andy, there you go. Yes, thank you. This is a very nice prize. Whether you're an observer or an imager, Sky Tools 4 Visual and Imaging Bundle for Windows, so you can use it for visual and for imaging. I have Sky Tools version 3. I'm too cheap to upgrade, but it works just fine. This is a very, very handy tool. It makes lists, helps you track your observations. Very nice piece of code. And it goes to our very own Brian Lippincott. Brian. I don't know if steampunks use computers, but you know, if you ever come to the dark side, there you go. From Phyllis Knight of Nightwear, $75 value, a copy of Deep Sky Planner. I'm not familiar with this package, but it must be good if she's donating a door prize here for it. So it goes to Kurt Meyer. Kurt, there we go. From Stellarview, Vic Morris. Thank you, Stellarview. Optimus 13.5 millimeter eyepiece, Optimus Prime. Does this thing unfold any larger than this? Seriously? This is a big eyepiece. Look at that. Look at the picture of it. Doggone thing. Wow. Optimus Prime. And this one goes to Jim Marshall. There we go, Jim. Enjoy it in good health. Okay, a slight pause here. It is time for the grand prize drawings, and I'm going to try to keep my talking to a minimum here because, but I'm not going to be able to do that with at least one of the grand prizes because there's a lot of TSP history bound up in one of our grand prizes here. Okay, Madison, will you please stir them up? Our first grand prize is from Bruce Morrell at Astrofactors. It is a QHYS3 Series V2 planetary and guiding camera. So any of you people who won imaging type software out there, this will help you capture the very best image that you can. Either it's if you do planetary work or deep sky work and you need a guider. Looks like a very fine piece of equipment. I'm not personally familiar with it, but if it's here, it's great. This prize goes to ticket number 82986. 82986. Hey, there we go. From our friend Stephanie Anderson at Cloudbreak Optics. We got an ASI Air Mini last night, and she gave us another one tonight. And this is very, very nice for an imager. It consolidates all of this stuff in one little box. So you can get rid of a lot of cables and a lot of a mess. I think it's also got a Wi-Fi connection to it too. So this is really sweet. And this one goes to Danielle Rappaport. Come on, I know her. Oh, Danielle, all right. I didn't know your last name was Rappaport. This is not the planet Mars, but it might as well be. This is the holy hand grenade of Nagler. It is the Type 5, 31 millimeter. This is awesome. I'm so glad to see this back, because I was telling people many times this past week and before that about the holy hand grenade and how Al was very generous to donate holy hand grenades to TSP throughout the years. I am so happy to see this back. It is as awesome as everybody says it is. And they always say, once you go Teleview, nothing else will do. I'm serious. Al's designs live on through his son David, who has taken over day-to-day management of the company. So David, thank you very much. This is a fantastic eyepiece. Drum roll, please. Reed Ship. Congratulations, Reed. Also, condolences. You will never be able to use another eyepiece the rest of your life. You will die destitute because you will spend all your money buying every ethos and delos and Type 4 there is and Type 5 there is out there, because nothing more will do. Everyone, this has been a blast this week. I know we've had 2 clear nights and parts of 2 other nights that were clear. Too many people bailed because they put too much faith in unreliable long-range forecasts. But those who did come got some observing, got to hear some of the very best presentations. In the afternoon paper presentations, our evening speakers, Dr. Stern, thank you again. We really loved having you here. Where's Carl? He's supposed to... We hope to see you back again next year. I believe the dates. I think the date is May 7th. But don't quote me on this. We'll make a formal announcement on the website when that will be. I'm not sure what the date is. But also, please consider joining us for the total solar eclipse viewing at Latham Springs. We're going to have that'll be a blast, and I swear you will not find a better value anywhere in the country. As the time approaches, people are going to get very unreasonable about the rates they're going to charge. So come spend it with friends, people who love you, and we'll all have an excellent time seeing the eclipse. We're going to get as much totality time as you can with the best possible weather prospects in the lower 48. So we hope to see you there. Hope to see you next year. Thanks again for coming. Safe travels home, everyone.
Everyone, sorry, my voice is loud. If you are in a motel room or if you are in a cabin, tomorrow, please take the paper, the plastic bags off the windows, put the light bulbs back in. It'll make the dark out crew's life a lot easier. 30 minutes, you have 30 minutes. And that's it. Thank you so much. Y'all have a good night.
Yeah, not tomorrow, sorry, Sunday, but although it might...
We're very pleased to announce our new StarSense Explorer Dobsonians. The telescope tube features a larger aperture than the other StarSense Explorer telescopes. It also has a 2-inch Crayford focuser that accepts both 2-inch and 1 1/4 format eyepieces, and also has a custom pointing knob to help you precisely aim the telescope at your target. Both the tube and base have carry handles at their balance points. And of course, the exciting StarSense Explorer dock. Simply place your smartphone in the dock and launch the app. Choose from the best objects to view, then just move the telescope to follow the arrows to your target. When it's ready to view, the bullseye turns green. It's easy to do because of the patented StarSense technology.
Hi everyone, we hope you'll enjoy the presentations we're bringing to you virtually from the Texas Star Party. We wanted to thank everyone who has taken the time to make this event what it is. TSP is a 501c3 nonprofit organization, and it's made possible every year by the help of people just like you. If you like these presentations and would like to help further the Star Party, you can throw a few bucks or a few thousand in our virtual tip jar by donating today. And it's tax deductible too. Make sure to share these videos with your friends, any clubs you're a part of, and most of all, remember to have fun. We hope to see you in person next year.